Good morning, my name is Napurski. We're going to go ahead and solve a Class A subnetting example, and we're going to look for 6 subnets on the 10.0.0.0 network. Okay, default subnet mask is /8, that's prefix notation. Step 1 again, let's go ahead and show the number of subnets in binary. That gets us 6. We're going to invert that, or flip it. And then in order to successfully create a valid mask, we're going to turn on all the high order bits from the last bit borrowed to the left. And that gets us our new mask. Okay, 255, 224, 00, or on prefix notation /11. Let's figure out how many subnets we're going to get. 2 to the n minus 2, where n is the number of bits borrowed. Remember, we borrowed 3 bits here. So 2 to the 3rd minus 2. Gives us 6. This is not 16. That gives us 6. That's exactly what we wanted, so check. We've solved. Now, the number of bits left over. This is a little more complicated. We're going to figure out the number of bits that we have not used. We have not used the remaining 5 bits in the second octet, nor have we reused the remaining 16 bits in the remaining 2 octets, the 3rd and 4th. So that gets us a pretty big number, 21. To the 21st minus 2, 2,097,150. Hosts per subnet. That's one really big campus network. Next, we'd like to calculate the block size. The block size is equal to the lowest high order bit that we borrowed. So in this case, I equals 32. And this will now allow us to calculate the valid range of addresses. Notice our checks here before we go on. We started with 8 bits. Plus an additional 3 plus 21 gets us 32. So we're still working with a 32-bit scheme. So starting in the octet where we're working, which is the second octet, is where we're borrowing bits. We will go ahead and start adding the block size, and then continue to do so until we reach the subnet mask. When we're done, throw out first and last, count them up. 1, 2, 3, 4, 5, 6. We said we'd get 6, we've got 6. We have a 32-bit scheme. We've solved for a very large number of hosts per subnet, and we've got our new mask. So far we're doing great solving this problem. So let's go ahead and move the camera. And now we're going to show the range of valid addresses for the 64 network. all I've done is draw our new network mask, right? 11 bits, notice the prefix notation, /11. Now I'm going to go ahead and draw the network ID for the 1064 network. Let's note that we're masking the first 11 bits. So from here back, we are actually not going to be changing anything for the remainder of the problem. So let's go ahead and draw the minimum host ID. And then let's go ahead and draw the maximum. Notice the minimum was all host bits off except for 1. The maximum is going to be all host bits on except for 1. And the broadcast will be all host bits turned on. The reason we were able to get 2 million hosts per subnet here is, for example, we will have each combination of binaries starting with, for example, just 1, then this bit goes off, 2 goes on, these 2 bits go off, 3 go on. We keep doing this, and then each time we get through all combinations in the first octet, we slide over and turn 1 bit on in the next octet, and so on and so forth. So we have 3 octets to work in. This is how we're going to get such a large number of hosts per subnet.